Hey guys, well let's have a quick look at projectile motion. Now projectile motion is one of the early questions you're going to get in your physics paper, and the good news is there's only a few different ways that they can throw this at you. There's 4 basic scenarios in projectile motion that you might come across. So let's have a quick look at each one of them. It kind of builds, each one is going to be a little bit more exciting than the one before. So the first scenario is where the object is simply dropped, okay, and it falls down to the ground. So we could say the object goes from A to B. And because it is dropped, that key word helps us to understand something important. What is it? The VI is 0. Very helpful little piece of information. So because VI is 0, it makes a whole lot of your equations a lot easier because that whole term falls out. So that's the simplest scenario. The second scenario we might get is very similar. The object is still just going in one direction, but this time it's thrown down. So it does in fact have an initial velocity. So it's still going from A to B, but it is thrown down with an initial velocity of some description. Okay, still not super complicated. Let's move on to the third scenario. Now here things start to get a little bit interesting. In the third scenario, the object is thrown up from the ground, perhaps, and then comes back down to where it started. Now the reason this is interesting is because our path, the path that the ball took or the object took, now has 2 different parts to it. The upward journey and the downward journey. So we can then label things in. Now you've noticed I've already been doing these little letters. I call these milestones, and it's so helpful to have them as a personal reference. The examiner doesn't need them, but it helps you know which part of the journey you're looking at. Because that's one of the easiest mistakes to make with projectile motion. You take a value and you just throw it into a formula like we were talking about with RefWord just now, and what you end up doing is you're putting the wrong piece of information into the formula. That is like putting chocolate into your curry, okay? Or it's like putting tomato sauce on your ice cream. Not a good idea. So make sure that you get the right pieces of information to put into your formula by looking at which part of the journey we're talking about. Let me give you an example. This could be a question like, Kagiso is walking along one day with his cricket ball, and he throws it up in the air, and he catches it 4 seconds later. How high did it go? So the question gave us a nice piece of information, which you can immediately write down. Delta t is 4 seconds. Then it said, well, how high did it go? Now in your description or your diagram, you might write that, okay, delta y equals question mark. Cool, I'm on a roll, I'm on a roll. Now, a very important point with this kind of question, you might have spotted it already. The ball goes up from A, gets to B, and at B, something special happens. We know that at B, it stops for an instant and turns around. So we can say that that velocity is 0. I'm not going to put VF at that point because it could be A to B or B to C. So I'm just going to label for myself that V is 0 at the top here. Now, I'm thinking, okay, well, if I start at the bottom, then that can be my VF 0. I'll put that in my list. All right. So I'm doing well. I've got 2 things in there. I'm trying to find delta y. What else do I know? Ah, yes, it's free fall. Okay, so free fall means that the only force acting on it is gravity. Of course, I haven't put my direction in. Let me just squeeze that in on the side here. Plus and minus. So I'm thinking, okay, gravity is acting down. It's minus 9.8 meters per second squared. So I've got my 3 values plus the one I'm trying to find. I'm on a roll. But I've made a big mistake. Can you see it? What's happened is I'm trying to find delta y. Now delta y is from A to B. Okay, so I'm just going to put that here just for interest's sake. Okay, A to B. The time that it gave us, the question gave us, was from when Kagiso threw it to when he caught it. That is in fact from A to C. Whoops, I've just put tomato sauce on my ice cream, okay? So you can't use that 4 seconds in the formula. What are we going to have to do with it? Well, the 4 seconds was all the way for the entire journey. So if we want it from A to B, which is halfway, you can immediately say, well, for this particular question, I'm just going to put full over there. So I'm going to separate it from my table, and I'm going to say delta t is equal to 2 seconds. And now all of those values actually work for the right part of our meal, the right part of the story, from A to B. So that's the kind of thing that you have to do when you're processing these projectile motion questions, is think about which part of the journey am I dealing with, and make sure that everything in your list relates to that part of the journey. A to B, A to B, A to B, etc. Okay, so that is an example in the third scenario. The fourth one is even more exciting, but the good news is it's the same principles. So this would be the kind of scenario, might be from the top of a building, it could be from an air balloon that is rising up and something gets dropped. And you'll see that the object goes up, reaches a point of turning around, and then comes back down and goes past where it started. Okay? So that now, if I put in my milestones, it has A, B, like the previous one, where we know that V equals 0 if we happen to need that. I would maybe say we could need C, which is going past where it started, but now we've got a new point at the bottom, which is now going to be going faster right down at the bottom of the ground there. Okay, so the principles are exactly the same. So when you're putting your list together, remember, consider which direction it is and whether it's a plus or a minus. So for example, if it went from A to D, the delta Y from A to D is going to end up being negative because it's traveled down. Okay, so the delta Y, I won't make equal to anything, but we know that that's going to work out to be a negative value and so on. So if it was on a 30-meter building, we would say A to D is minus 30 meters. All right. So the principles otherwise are very similar to what we did in scenario 3. Cool. There's one more. Okay, so this is not for the faint of heart. This is the kind of question that when you open the paper you think, yes, they've given me one of these challenging ones. And that is not a one-object problem, it's a two-object problem. All right. Same principles apply, but you're just going to have to do the two halves and then put them together. So let's say Kagiso is now standing on top of a building and he sees his friend Lorato downstairs. And he's got an apple in his hand and she's got an orange, and they say, well, I would like your apple and I'd like your orange. So they're going to swap over. So they have an attempt and Kagiso drops the apple and Lorato throws up her orange and they miss each other. Kind of, they're giving a picture of the scenario. And the kind of question would be, at what height did the apple and orange pass each other? Or at what time did they pass each other? So it could be either of those two scenarios. Now, you've got the understanding from our previous examples of how to solve either of those problems. Put your list of values together. So in this case, we're going to have Kagiso's list of values, and then we're going to have Lorato's list of values, and you can start to populate that with the information that you know. But what you'll find is that you don't have enough information on either side to solve either of them. And so you get stuck with too many unknowns, too many letters still amongst your numbers. So when you've got two unknowns or too many unknowns, I'm sure some of you got it already, we're going to have to combine those two equations together and we're going to use simultaneous equations. Okay, so that's where things would go with that kind of question. Now, even if you get lost in the woods somewhere as you're trying to do all these calculations, you can still get lots of marks by identifying Kagiso's scenario, write the correct formula, substitute in the values. Remember, sticking with his values, all right? Then you look at Lorato's values and you put all her values, your correct formula, correct substitutions. That's most of your marks already done. And if the simultaneous equations gets a bit confusing, don't allow yourself to get stuck on things there. Just give it a good 5 minutes, 10 minutes at the very, very most, but then you've got to move on to the next question, maybe come back to it at the end of the paper if you're struggling with it. But you know what? With a bit of practice, you're going to nail it. So let's just quickly review what you're going to do. Don't forget REFWA. So writing your list of information, checking your milestones, super important. Then, from there on, it's pretty straightforward. Practice. And practice, and practice. And you're going to get really good at this. All the best. Cheers.